everyone! Welcome back to integralcalc.com. Today we're going to be sketching the graph of a circle, and the equation of the circle is 9x squared plus 9y squared minus 6x minus 12y equals 11. We're going to be using this formula here, and what we want to do is transform the equation we were given into the form given in this formula here. And when we've got it in that form, we're going to look at x sub 1 and y sub 1. We'll pull out those two pieces of information, and that will give us the coordinates of the center of our circle. And we'll also grab the radius from right here, and when we have the coordinates of the center and the radius, we'll be able to draw our perfect circle around that center, and that'll be all the information we need to complete our problem. So what we need to do first in order to convert our equation into the form given in this formula is divide through the entire equation by 9. And the reason we need to do that is because we need to make the coefficient on the x squared term and the y squared term equal to 1. Right now it's equal to 9, so we need to divide through everything by 9 in order to get that to be 1. So when we divide through by 9, we'll get x squared plus y squared minus 6 over 9 will reduce to 2/3. So 2/3 x minus 12 over 9 will reduce to 4/3. So minus 4/3 y equals 11. 11 ninths. So we divide everything through by 9. Then we need to group our x terms and our y terms together. We're not going to perform any operations, we're just going to reorder the terms so that the x's and y's are grouped together. So we'll say x squared minus 2/3 x, and we'll put that in parentheses to distinguish that it's its own group. And then we'll add to that the y group, which will be y squared minus 4/3 y. And of course that's equal to 11 ninths. You also want to make sure when you group your x's and your y's together that you at the same time move all of your constants over to the right hand side. In our case that's already done. We've got 11 ninths on the right hand side and no other constants on the left. But if you had another constant hanging out, you'd want to move that to the right hand side and combine it with your 11 ninths right there. So once we've got everything in this form, we need to complete the square with regards to both x and y. And the way that we do that is standard for any completing the square procedure. What you do is you take the coefficient on your first degree term. Your second degree term is x squared, second degree because the exponent is 2. So your second degree terms are x squared and y squared. Your first degree terms are raised to the power of 1, so that's your x term right here and your y term right here. We want to take the coefficients on our first degree terms. So when we complete the square with respect to x, we're going to take the coefficient on our first degree term, which is negative 2/3. So we're going to take that coefficient, negative 2/3, and completing the square tells us we need to divide that coefficient by 2. So negative 2/3 divided by 2 is going to be negative, 1/3. So negative 1/3, whatever we get for our answer, we then square it. So negative 1/3 squared gives us a positive 1/9. Now we'll do the same thing with respect to y. We're going to take the coefficient on our first degree term, which is negative 4/3. So negative 4/3 divided by 2. And when we do that, we'll get, 4/3 times 1/2 would be 2/3. So we'll get negative 2/3. And we take that answer and square it. So negative 2/3 squared gives us a positive 4 ninths. So now that we've got that, what we want to do is add that, or add these to our equation to complete the square. So we'll get x squared minus 2/3 x, and then we want to add this to our x terms, and that completes the square. I'll show you why in a second. So plus 1/9 plus y squared minus 4/3 y plus 4/9, right? Because we got that here when we completed the square with respect to y. But then we need to remember to add 1/9 and 4/9 to the right-hand side as well. We can't just add them to the left-hand side. It unbalances our equation. So we have to add 1/9 and 4/9 to the right-hand side as well. So add it to the left, but then make sure you add it to the right. So now this completes the square, because if we factor our x group right here, we'll get, let's see, x minus 1/3 times x minus 1/3. If we factor the y group, we'll get y, let's see, minus 2/3, y minus 2/3 times y minus 2/3, and that's equal to 11, 12, 16 ninths. So the reason that it's called completing the square is because when you do that, you end up with perfect squares. Notice that our factors here are the same. X minus 1/3 and x minus 1/3 are identical. Y minus 2/3 and y minus 2/3 are identical. So we can rewrite that as x minus 1/3 squared, and the quantity y minus 2/3 squared equals 16 ninths. So now you can see our equation is in the exact same form as our formula right here. So we can now take out the coordinates of the center of our circle and our radius. So the coordinates of our center are going to be 1/3, 2/3, because, right, we see x sub 1 here and y sub 1 here. It's very important to remember that in your formula you've got negative signs right here. So if we have negative signs, we can just take the number 1/3 and 2/3. If we had a positive sign, we would have to, instead of just taking 1/3, we'd have to take negative 1/3 in order to match the form of the equation. But because we've got negative signs in our formula and negative signs in our factors, we can just take 1/3 and 2/3. So our center is at the point 1/3, 2/3. Our radius, notice that our formula tells us that the radius is going to be the square root of the right-hand side. So the right-hand side is the radius squared. So in order to find just the radius on its own, we have to take the square root of the right-hand side. And when we do that, we'll get 4/3. You can take the square root of the numerator and the denominator separately. The square root of 16 is 4, and the square root of 9 is 3. So our radius is equal to 4/3. So knowing that information, we can then graph our circle. So we'll mark off our axes in increments of 1/3. So there's 1/3, 2/3, 1, 1/3, 2/3, 1, 1/3, 2/3, 1, 1/3, 2/3, 1. Okay, so our radius is at 1/3, 2/3. So right here, or sorry, our center, and then our radius is 4/3, so it's 1 1/3. So we need to move over 4 tick marks. So 1, 2, 3, 4, about here. It's going to be a big circle. 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Something about there. So we're going to go into our problem here, but it's going to look about like this if the axes are marked off in increments of 1/3. That is an ugly circle, but this is 1/3 and 1/3 right here. So that's all we do. We find the coordinates of our center, and then we move out in a direction of, or in a distance of the radius in every direction, and then draw a circle around the center. So you would draw the circle like that, and then you would, on your test, draw the circle and then say the center is at 1/3, 2/3, and the radius of this circle is 4/3. So that's it. I hope this video helped you guys, and I will see you in the next one.